Number 47, Chapter 7 review. It says to use the shell method going around the y-axis. So we have y equals x minus 3. I'll graph it here. So y equals x minus 3. Looks like this. X squared minus 3x. So x times x minus 3, it has x-intercepts at 0 and at 3. So 0. This one crosses at 3. Alright, so it looks like that. And we're going around the y-axis. Alright, so around the y-axis, you could consider doing a washer method because it's hollow. Your big R would be this and that. It's not going to work because we have the same equation for your big R and your little r down here. And if you went washer with a vertical axis of revolution, then the integral would be with respect to y. We cannot solve for x here and write x as a function of y, but it's not algebraically possible, so we can't integrate with respect to y. We have to integrate with respect to x. So if we're going vertical and we have to do dx, then it means that we have to use the shell. So the instructions said to use shell. I'm just kind of quickly explaining why shell is really our only option. So we're going dx, which means we're going from here to here on the x-axis. So let's see. Let's set them equal to each other. So 1 and 3. So there's 1 and there's 3. So we're integrating from 1 to 3. And now it's integral of 2 pi r h dx. Alright, using the shell, we draw a line segment parallel to your axis of revolution through the area, and that is going to be your h, and connect that with the axis of revolution, that is your r. So now we have to write r and h in terms of x. So r, anytime you're going out from the y-axis, it's always going to be x. And your h is just going to be top minus bottom. So the top one in terms of x is just x minus 3, minus the bottom one in terms of x is x squared minus 3x. So that is the integral that will give you the volume using the shell technique.